Good morning. Hello. Welcome, everybody, to our talk today on what's new in Android developer tools. It is awesome to see so many developers here from around the world and in a concert venue. I just want you guys to know, this is pretty cool for us. I'm Steph Cuthbertson. I'm here today with the wonderful Tor Norby and the wonderful Jamal Eason. We're going to give you an insider's tour of Android Studio. And for those of you who are already real insiders and notice that Zav is not on the stage this year, I'm just filling in for him. He's actually on a beach in Hawaii, so hello, Zav. When we first started working on Android Studio, you know we wanted a purpose-built IDE, which was tuned for our languages. That's why we picked IntelliJ, and native to the Android platform. Now, Android Studio has built tremendous momentum in a short period of time. One of the things we announced yesterday is that now 92% of the top 125 apps and games use Android Studio. Since we announced it here at I/O 3 years ago, and you may remember it was Tor who did the demo, we've released 131 times across our preview, beta, and stable releases. And what that reflects is actually a big part of what's driving our success. We have an incredibly engaged developer community, trying all of our early builds and giving us wonderful feedback. That is what's letting the team focus and helping us go very quickly. We've been thinking a lot the past year about what else we could do to help accelerate productivity and make your lives better. So for those of you in the audience who don't know Android Studio quite as well, I'm going to give you a whirlwind tour of 2016 and what we've done so far, just in about 60 seconds. So I'll bring everybody up to the same level, and then we'll go on and talk about 2.2 and the road ahead. So already this year, we launched 2.0. That focused on speed with the introduction of Instant Run and the emulators. We also launched wonderful new emulator UI, the GPU debugger preview, search deep linking creation, testing, and much more. That shortly followed 2.1, which we built side by side with N. And that brings you support for all N's features and APIs. It brings you emulators, so you can test N. The new Jack compiler, so you can try out Java 8 support. And in particular, in 2.1, we also accelerated Instant Run. And the way we did that was by moving our deck step to happen in process, which gave us wonderful speed advances. Now, all of this brings us now to 2.2, which focuses on speed, smarts, and Android platform support. Now, one of the things that's wonderful for us about I/O is this is a developer audience. So what we're going to do is spend the first 25 minutes of today's talk giving you a live demo of nearly every single feature in the 2.2 preview, which you can also use. Now, just a reminder, this is a preview build, so expect preview quality. And then we'll do the normal thing we always do. Over the next several weeks, we'll be stabilizing this as we move through beta and stable. After that, Jamal and I will then take it back, and we'll walk you through design, develop, build, and test to give you a nice structured overview with screenshots, and also take you behind the scenes to talk more about how and why features were built. So with that, to take you on a lap around 2.2, would you guys please give a very warm welcome to Tor Norby. Thank you.
All right. Can you see the screen? Demo. All right. Can we get the demo machine? Thank you. All right. So I'm going to start with something very small and simple, but I think you'll like it. So we released a lot of SDK components yesterday. And once you've installed Android Studio 2.2 and you go to install them, notice how we have a background button now. So you can keep coding while you're installing the latest goodies. So we spent the last year focusing on making builds faster. We know that's a top concern for all of you. And so I'm going to show you where we are with Instant Run right now. So this is the I/O app running on the right. And I can go ahead and comment out some code here and run it. And when I make that change, you can see that within about a second, it reflects that change on the device. That would take 15 seconds without instant run. I can also make some incompatible changes, for example, extracting this into a method. And making that change is another second or two to deploy. So after the demo, Steph is going to talk more about what it is we're doing next with Instant Run in 2.2 and 2.3. So one of the things we had to do when we worked on Instant Run was figure out what's going on inside the APK files. So to do that, we built this new feature, the APK Analyzer. So I can open up any APK, or the one in my project, and now I can drill into what's going on in the file. So I can see, for example, what's inside the assets folder or the rest folder, or in this case, Instant Run, the way we're repackaging your application into slices. So let me drag in a real production app, the Chrome APK. The purpose of this tool, there's a couple of things. First one is to be able to look at the download size. So in some markets, it's very important that you make the download small and the install size small. So this lets you look at what is actually in your app and focus on whether you can get rid of it. So I can drill into the assets folder and look at the files. I can look at the, let's say, layout folder. We decompile the binary XML back into source, although we need to do a better job with the resource references. So soon, we will map those back into resource names. You can also look at the string or the value table, which has been sort of an opaque file to look at before. Now we have a viewer, so you can go in and see just what's inside. And last but not least, yes. And last but not least, this lets you look at the DEX files. So you're probably all aware of the 64K method limit. It's not actually a method limit. It's method plus reference limit. So you can now drill into this and see what is it that you're declaring and what is it that you're referencing to see how you can get below that 64K or turn on multi-DEX. So if you ever looked at a manifest file in the build outputs, you might have noticed there's a lot of stuff in the manifest file that you did not write, right? Where did it come from? Well, we have a new editor in 2.2, the manifest editor. So this is the XML tab, but you can see on the bottom there's now a merged manifest tab. And when I click on that, you can see that we now give you the full merge, updated live whenever you make edits. There's a legend on the right which tells you where stuff is coming from. So for example, I can see now the internet permission is coming from Play Services. So I can also go in here and navigate to the line that is the source for the merge. So hopefully that'll help demystify what's going on with the Gradle manifest merging process. So speaking of Gradle, we don't want you to have to learn how to edit build files in order to configure your project. So we're in the middle of a complete rewrite of the project structure dialog. And I say middle because all we've done so far is dependencies, though arguably it's probably the hardest part. So my favorite part in the new PSD is the messages pane. So what this shows me is suggestions the IDE is making. So you can see here, my project happens to be using JCenter for dependencies. And it's telling me, hey, there's a newer version of this dependency available. And all I have to do is click on this update link. Now I'm using the latest version. I can also click on Update All to take all suggestions. So notice, this is not just looking at local repositories, which Lint used to do for you. It goes out and searches remote repositories as well. If I switch to the dependencies view, I can drill into the dependencies either by module, or I can look at the overall dependencies for all modules across the project. And I can drill in and see, for example, the transitive dependencies to see basically how I'm reaching certain dependencies in my project. I can also go and add dependencies. So we have a nice UI now where I can go and search. Again, just like with the updates, with the update suggestions, this looks at remote repositories. It also looks at local repositories. It shows all the available versions. And it even helps me tweak the scope string in the dependency list. So you can turn this on today in the experimental settings if you want to play with it. And we're going to be trying to finish that in the next couple of releases. Next, let's talk about C++. So last year, we showed you that we have really great editing support. This is the CLion C++ functionality from JetBrains that we've integrated. And however, it required you to use the experimental Gradle plugin. And the big news for 2.2 is that we've now added support for external build systems. So you can actually use CMake to build your native code. You just declare it like so with a stable plugin, and now you can build C++. And for C++, we will have a wizard in the next couple of builds, so you can very easily go in and add C++ support to your project. And when you do that, you end up with a sample project that looks exactly like this one. So you have a main activity that loads a native library, and then you have a sample hello world native library string. So let's hook this up. I'm going to first of all, set a breakpoint here in the C++ code. This main activity is just showing the default layout that has a string in the middle. So let me go back and change that string to show the value from C++. So we'll do text view equals find view by ID. And then we'll hook up that ID. We've got to cast it. And then we will call set text on that text with the call from C++. Now let's also set a breakpoint here. So now I'm going to launch the debugger. This runs Gradle, which runs CMake, builds everything, packages it. And in a second, this app should be running on the emulator. There it is. So we hit our breakpoint. Now we're in Java code. And so you can obviously be looking around at your manifest state. Activity state. And if I resume the debugger now, you can see now we're in C++. And I can drill around. So that's the hybrid debugger and the CMake support. The last thing I'll show you in the build system area is something on the command line. So let's say that you've gotten a project from a coworker, or maybe you did a Git pull, and someone changed the build tools version, or let's say the compile SDK version in your project. And then you build, and then you hit a message like this one. You don't have build tools 2201. What do you do now? You open SDK Manager, you install it, right? Well, in 2.2 Alpha 1, we now have an experimental flag you can set. And when I run the build, if I've already agreed to this license, Gradle will just go and download it for me on the fly, as you can see right here. Yeah. So that should also make configuring continuous integration servers a lot easier. All right, let's go from the extreme of command line to visual editors. So let's take a look at our new layout editor. Actually, I shouldn't call it layout editor because it does more than layouts. So first of all, I can open up a menu file. Here's a menu. I can drag and drop design menus now. We can also open up preference files. And I can drag and drop preference files. And obviously, there's a component inspector.
You did a really nice job on this.
But of course, layouts are a big part of this. So you can see we have a new component inspector on the right. This one shows you the important attributes for the selected component, text view in this case. So if, for example, for text view, we show you the text appearance. And notice how there's some gray text here in the component inspector. Even though I haven't set the text appearance, we're showing you what it actually is going to be at runtime. So I can see the font will be 14 SPs, for example. If I switch to something else, it'll compute what that should be. Now, we only have a subset of the properties here to make it simple to find. But if you need anything else, the full set of properties is just a click away up here. So on the design surface, we have blueprint mode. So blueprint mode is basically showing the structure. It's like an X-ray of what your app is doing. And I can have blueprint mode and design mode on side by side. And one new thing we have that you've asked for is, here, this is a scroll view. And I can now scroll the design surface directly. Now, blueprint mode is particularly useful for the new constraint layout. So let's take a look at constraint layout. So first of all, I'm going to turn off auto connect mode. So let's drag in some components. So we'll put a text view here. We'll put a edit text, another text view, and another password field maybe. And then we'll add some buttons on the bottom right. So you can notice I'm being kind of sloppy because after the fact, I can go in and I can make a selection. I can right-click and say, hey, I want to align these things on the bottom. I want to align all these things on the left. Maybe I also want to pack them vertically. So here I have my design. Now let's see what happens if I go to landscape mode. That's not good, right? So I have buttons off screen. So let's try to fix that. So there's this little light bulb icon for infer constraints. Notice what happens when I click it. I now have these constraints where it's tried to guess what we probably mean here. And when I try to resize this now, you can see the buttons are moving correctly. So normally, you're actually in auto-connect mode. So if I want to drag in a button here, you can see that the second I drop it, it actually goes and adds these constraints for me. And if I don't like them, of course, I can delete the constraint by just clicking on them. I can also drag new constraints. And we sort of show you a preview what it's going to do when you commit to it. And the constraints can also have strength. So as I'm dragging, you can see it auto-snaps to a quarter or specific percentage. Someone asked yesterday if this also works from XML editing, if that's what you prefer, and why, yes, it does. You can see here we are in XML. I can continue to play with the constraints over here. And you can see the XML editing works just fine as well. So this is a very powerful, thank you. So this is a very powerful constraint solver. And what that lets you do is flatten your layout hierarchies. And that's very, very, very good for performance. So we've added a feature to help jumpstart that. So let me open this other layout, this one. Let me switch to blueprint mode so you can sort of see what's going on. So here's a layout that is actually a set of nested linear layouts. And if I now go and say convert this linear layout to a constraint layout, it offers to flatten the whole thing. And as you can see, visually it looks the same now, except we have constraints. And on the left, you can see a single flat list. All right, let's go look at editing. So in the editing area, we've added a couple of features. So first of all, there's the Firebase integration. So if you're trying to accomplish a task with Firebase, for example, you want to add crash reporting, you just open up the assistant window, and you pick the task you want to do. So for example, crash reporting, you drill into this. You can see you get this step-by-step set of instructions that sits next to your source editor. And if you, for example, see that you want to perform these lines, you can just drag it into your source code to make that edit, for example. If you are trying to figure out how to use an API, so let's say you've heard you should use the job scheduler, and yes, you should use the job scheduler. You can right-click on it, and you can say, find me some sample code for this. So as you can see, it basically goes to the server and finds recommended samples that you can then drill into, and you can right-click and say, open this in a browser and let me learn more about this. 2.2 is based on IntelliJ 16.1, so we have a number of new features for that as well. So one thing we got is support for editing bidirectional strings. So this is something our international audience has been asking for a while. So here we have some Arabic texts, and you can see the source editor is now more than happy to handle this correctly. I know this has been a big pain point, so finally we've got it. Thank you, IntelliJ. So IntelliJ 16 also comes with a bunch of new inspections in the editors. And on top of that, we've added into a number of new inspections that are Android specific. So let's take a look at those. So first of all, hopefully everyone knows that it's really, really bad practice to solve the problem of passing data from activities by making your field static. That's a no-no. And now lint will flag it for you, not just because it's a leak, but also it makes Instant Run very happy when you do this. This is also not as simple as just this case. For example, we have, if I make these other fields here static, AppData1 is no problem, but AppData2, turns out that one, it has instant state that is a context, but now there's a static reference to it, which is bad. So let's look at some of the new support annotations. We released the support library yesterday, and there's some new good ones. So first of all, you can now finally say, hey, this method, even though it's inside of a worker thread class, this one is thread safe. You can call it from any thread. For a while, we've had API check. So lint will look at the platform APIs and compare them to your min-SDK. And we have a quick fix where you can say, well, OK, insert that check for me. However, what you can now do is you can say, I expect my method to require this API. So you're passing on the responsibility to call each of your APIs. So you can now get API check for your libraries to clients. So you can see now these other calls, even though they're calling your API, the API check is applied. The next thing I will do is show you the dimension resource, the dimension annotation. So this one lets you say, this integer represents a dimension. And there are various units you can apply. Now, it turns out pixel is very, very important. Most APIs in the SDK operate in the pixel space. So we have a new annotation to just say pixels. So that's at px. And when I do that, you can see we're now flagging incorrect usages where you're passing a dimension resource that should be a dimension. So hopefully that'll be useful. And the last annotation I want to highlight is the keep annotation. So you can put keep on your methods and classes. And as of, yes? So as of Gradle plugin 2.2, we now automatically make sure that if you use ProGuard or the new incremental shrinker, these methods will not be removed at release time. So if you like the support annotations, we have a feature that I think will make them even more useful to you. And that's the new inference. So IntelliJ has for a while had this analysis action to infer nullity. Well, we have a new feature. It's behind a flag, but you can try it if you want, to infer support annotations. So when I run this on the current file, it basically does a bunch of analysis to figure out a lot of new annotations based on usage in your project. So if I go back into my file here, all the diff markers you see here are for new annotations that it figured out. For example, there's a permission requirement here. So that'll hopefully help jumpstart annotations and will help Lint find more bugs in your code. We've also been collaborating with a research team at Oregon State University to work on permissions. So this is still a work in progress. But when this is done, this will let you migrate your app to Android M permissions. So here, I can invoke this action. It'll help me perform the right requests and handle callbacks for Android M permissions. We also have a refactoring to remove unused resources. So if I add some resources that aren't actually used, I can now just go to the refactor menu, say remove unused resources, and the IDE will find them and nuke them for you, which helps make your app leaner. All right, so now last thing I want to show you is the Espresso test recorder. I'm hearing ooh in the audience. All right, so to do that, all I have to do is go into my project and go to the Run menu and say Record Espresso Test. And note that it's espresso, not expresso. And so when I do that, you can see that it actually builds the app. And it starts this event recorder on the left here. And on the right, we have our app running. So now I can, for example, go and click on this category over here. And you can see it records an event for that. And I can click on the back button. And then I can go down and, let's say, click on the music tile. Notice as I'm clicking, it's recording the events over here. And it tries to make sense of what it is I'm clicking. So for example, when I click on the red button, it's recording that I clicked the Fab Quiz button. And so another cool thing I can do while I'm recording, I can add assertions. So I'm going to click on the Add Assertion button here. And it's now pulling down a screenshot in view hierarchy of what's going on in the app. And I can now, you can see I can move around in the logical structure of the app. And if I click, for example, on the question, who was the youngest Beatle? It pulls that down and it suggests an assertion, which is, hey, at this point, when the test is running, we expect this string to be who was the youngest Beatle. So then I press Save Assertion, and I keep going. So does anyone, I'm going to click some wrong answers until you stop me. So, all right, still wrong, still wrong. George is right. OK, and then I'm going to finally click on the Submit button. And you can see that that was the correct answer. And I think that's probably good enough for the test recording part. Now I'm going to say Complete Recording. When I do that, it's asking me what class I want to save this test as. I'm just going to accept the default. And here we have our espresso test. So notice that I clicked some wrong stuff in the beginning. I can now edit this test if I want. So for example, I can take out the, clicking the wrong tile and going back. And then I can run the test. So let's do that. So all I have to do is click on this Run button right here. And you can actually use cloud testing as well. I don't have time to show it, but you can sign up for that. And then it'll run your UI test across a number of different hardware form factors, which is pretty useful. All right, so let's just run this on the emulator again. So it's going to build a test, deploy it, and let's look over on the right here when the app starts running, because it actually can click faster than I can. Installing APK. Here we go. Click, click, click. And we have our green pass. All right. Thank you. So with that, I'm going to turn it back over to Jamal, who's going to be talking about the visual editors.
So thanks, Tor. Great demo. So what Tor showed you is what we're doing. I'm going to spend a little time talking about why we're doing it and why you might want to integrate it into your development workflow.
You have more time.
So for design, we're thinking about two main topics, XML and layouts. So for XML, I know a few of you enjoy designing your entire UI in XML. That's great. I know for me and many others, it's great to have some sort of visualization tool to allow you to see how your app is going to render. And our team set a goal for ourselves thinking about, is it possible for us to create a tool where no XML editing is required? Of course, that means you can always look into your code afterwards, but it shouldn't be in the way to get your job done. So that was the reason behind the new layout editor. And as Tor showed you, we have a whole host of new features, including ways to drag widgets onto the component tree onto the design surface, or the new blueprint mode, which allows you to peer behind your application to see how all your widgets connect together. And lastly, the new properties panel. In the past, we used to show you all the different properties that were available for a view. Now we curated those and showed you the most impactful attributes to use for your particular view layout. The second question you're thinking about is around layouts. So for Android layouts, you have a couple different options. You have the linear layout, of course, horizontal and linear. But then you're thinking, well, perhaps I need to use the frame layout or the table layout. Wait, that's not going to work, actually. Let's think about using the grid layout or the relative layout. Wait, so which one should we use here? That's the problem we're trying to think about, because many times we're thinking about, which container should I use for my layouts? So the constraint layout is the solution for this problem, where you can think less about the container and more about the content and how you lay out your widgets on your layouts. So let's talk about why you might want to use the constraint layout. So number one, it's fast UI development. So as you saw in the demo, we can actually add widgets pretty quickly and connect all the different constraints. What is also very important to think about is that this helps you have more responsive design. So instead of thinking about, well, how does my screen fit on a Nexus 4 or a tablet or a Nexus 6 device, we can now create constraints that allows you to respond your content based on the screen size. And the third most important aspect is performance. So as you saw in the demonstration, we can now flatten your hierarchy for you. If you didn't know, if you put a relative layout underneath another linear layout and another relative layout, that actually is slower for the Android operating system to process. So all that nesting can be now flattened with a new constraint layout. And lastly, it's backwards compatible, which means you can use it obviously for new projects, but it's a support library that allows you to use it to existing projects as well. And so the third tool that we demonstrated around design is the layout inspector. So sometimes when you're loading your application, you're wondering, well, why is my view overlapping? Or perhaps, why is one of my attributes not what I expected it to be? So what you can do now with our tools is you can right-click and take a snapshot of your current layout and then visually inspect all the different attributes and look at the entire view hierarchy of your layout. So that should be very helpful in debugging. So now we'll spend a little bit of time talking about develop and what tools we've enabled to help you with that. So as we showed in the demo, we have now a new Firebase plugin. And this supports the new Firebase services that we launched yesterday at Google I/O. And you can now add things like Google Analytics, ads, cloud messaging, all in a click of a button inside of Android Studio 2.0. The other cool thing we talked about is the samples browser. And as demonstrated, if you're looking for an API example or how to use something, now we provide the power of all the Google samples at the click of a button. And so this makes it easier for you to now look and have a good starting point for your application development. And now with that, I'd like to talk a little bit about the build tools, and I'll invite Steph to talk about those new changes.
Cool. Thanks very much, Jamal. For build, I want to start by talking about Instant Run. Now, as a developer, I think one of the best feelings in the world is being in the flow. And one of our goals for Android is to make Android development feel as lightweight as web development. So you can make your code changes and then see them essentially refresh so that you can really stay in the flow as you're coding. That's why we built Instant Run. So I want to talk a little bit first about how it works. The IDE swaps your changes in one of three ways. For incremental changes, we do the fastest swap, which is called a hot swap. And here what we do is we instrument your bytecode on the first build. And then after that, when you make changes, we just redirect the code path to pick up the changed code. The second type of swap is a warm swap, and that's when we need to do an activity restart. So that's what you need whenever you're going to do, for instance, resource changes. Cold swaps are when we need to restart the app. And that's required when you do structural changes. So examples of those would be changes to inheritance, or if you change your method signature. So what I'd like to do is back up and unpack a little bit some of the benchmarks that we talked about yesterday in the keynote. We benchmarked using a wide range of different applications and different tools. I won't take you through all of it. Just one example. We benchmark with the Wikipedia app. It's an open source app. You can get it on GitHub. And I've posted here all of our criteria in case it's interesting to repeat them. What you'll notice is that we benchmark against 2.0 with Instant Run disabled. And you can see in 2.1 with Cold Swap, it's 4.7 times faster. And Hot Swap is 10.7 times faster. Now, what that means, if you think about it, is our build speeds are actually faster than 10x because we're benchmarking against 2.0. And 2.0 is faster than 1.5 because of changes we made in DEX. And we also made ADB push speeds 10 times faster. So we're underselling a little bit. But what we care about most is really that you guys are getting super fast builds. And so that's what we focused on. And this gives us a nice apples-to-apples comparison in our own benchmarks. Let me talk about another type of benchmarking we do. So we look at the user stats for users who opt in. And we instrument in a bunch of different, very cool ways. So for all of you guys who opt in, thank you. This is an example of a stat we look at. This is average run time, average build time for Instant Run on Hot Swap. And this is showing across all users. So this is worldwide, all operating systems, all countries, all hardware, and that includes very old hardware with slow processors and things of that nature. What you can see is that most users are seeing Hot Swap happen in 4 to 5 seconds or less. And our goal is always to push that graph over. We're trying to make as many as possible happen in 1 second. So what we look for is we're trying to figure out how do we drive full build speeds down, how do we make hot swaps faster, and how do we make as many swaps as possible be hot swaps. So we look at things like this. We look at the distribution of hot swaps, warm swaps, and cold swaps, and full build times, as well as what's causing cold swaps to happen. And it was looking at that instrumentation, really all of your wonderful data, that gave us the clue for one of the big changes you'll see in 2.2. So 2.2 includes a change to AAPT. A lot of you guys know when you change a resource, AAPT inserts an ID in the manifest. Now, what you may not know, and what we didn't know, is that if you change a resource or add a new one, AAPT was renumbering those IDs. So the impact is you make a code change, but you would get a cold swap. We identified this was driving about, let's call it 16 to 19% of our cold swaps. So with 2.2, we've changed AAPT, so it holds all the resource IDs constant. So I'm kind of taking you guys on an insider's view of what will just occur to you in 2.2 as an acceleration in Instant Run, because you're going to see a lot more hot swaps. Another change we made is we're taking advantage of split APK. So now, when you build, we'll break your app into about 11 to 12 DEX files. And when you do a full build, we'll actually only rebuild the changed code. We plan to keep driving build speeds down in multiple successive releases, not 2.2. So if any of you guys are seeing still slow build speeds, the engineering team would really appreciate it if you come find us. Let me talk next about project structure. Now, Tor already gave a wonderful demo, so I'm just going to give you guys the insider's look. Underneath the project structure dialog is some very interesting changes to the Gradle build model. Now, Gradle has been wonderful for us. It's a very flexible language, very powerful for Android. But let's think about it. An IDE expects structured inputs, and Gradle is a programming language, so that's pretty complex. One of the changes we made in 2.2 is we completely rewrote the Gradle parser from the bottom up. So what that means is we're now much more accurate when we read in Gradle files, and we're also much more accurate in the IDE when we write them back out. So an example of what you'll see is, for instance, if you write variables into your Gradle file, we will now read those correctly in the IDE. And in the future, in the project structure dialog, you'll be able to modify those in the UI as well. The Gradle rewrite of the model is done already in 2.2. As Tor mentioned, the project structure dialog is partially complete in 2.2, and you'll be able to try it under an experimental flag. We plan to complete it in 2.3, and at that point, it will become the default. This is just a nice screenshot of the merge manifest viewer, which Tor also showed. For time, I want to skip ahead and talk a little bit about Jack. Now, the Jack compiler was integrated with Gradle in 2.1. And in 2.2, we now include annotation processing. So you can now use annotation processors on your class path. So this would include such as a compile dependency, and they'll be automatically applied. Now, detailed information about how to use this is in our docs. One of the things I wanted to call out here at I/O is if you are someone who's writing tools and doing pre or post processing on class files, one of the really nice things about Jack is that it has a structured API for manipulations. Now, we are going to be looking to move more and more to Jack in coming releases. So please do try this out, and let us know if there's anything that's missing for you. Our last topic will be C++ support. And for this, I'm going to give you guys the whole arc of what we're doing, because I think it's a nice way to just understand C++ from end to end. The reason we're investing so much is because we know there's a lot of you who are doing very graphics-rich apps and games, and you've talked to us and told us that C++ is critical. We already support C++ editing and debugging, and all of that is coming through IntelliJ. So one of the new things you're going to get with 2016.1 is also IntelliJ's wonderful improved support for C++. But I think the biggest change you'll see in 2.2 is CMake and Gradle. Let me walk through a CMake example. You can now reference a CMake project in your Gradle file, and this will build your SO files, so they're packaged in the APK. And how it works is Gradle now shells out to CMake, and we're getting CMake to emit more metadata about the project itself, both how to build it and what files are in the project. So that's how, as Tor was showing you, you're able to see the .cpp files show up in the project hierarchy, and you'll also get your .h files as well, if those are in the same folder. The files themselves will show up in a node in the project hierarchy as well under external build files, so you can edit those as well from the IDE. And just as Tor showed, you can then run the app, set a breakpoint. It'll all work as expected. Setting up NDK build works the same way, so you can reference an android.mk file from your build. I'd also like to give you guys a brief tour of the C++ debugger enhancements. So first, in 2.2, as we mentioned, you no longer have to explicitly choose the C++, Java, or hybrid debugger. You can just use auto, and the IDE will automatically select the right debugger for you. If you're debugging in N, you can actually use one single debugger for Java and C++. And then a final thing we added is watch points. So you can add a variable, and you can freeze the process if those are read or if they're modified. Watch points can be used on x86 and Nexus 9, and we're probably planning to bring more devices online. For now, a great way if you want to try them is to try them out with our emulators. We also fixed several compatibility issues with Samsung S5 and S6 devices. So that covers C++ and 2.2, and you should expect to continue to see enhancements in coming releases. The last area we'd like to talk about is testing. And so with that, I would love to bring Jamal back. Thank you guys very much.
So for testing, a core feature you need is a local testing environment. So we're really excited that we launched the Android emulator earlier this year. And if you haven't tried it, it's a great tool. What's great about it is that we improved the CPU, GPU, and I/O speeds, so it's even faster than the device. We've also improved the ADB speeds. Believe it or not, many times the bottlenecks between you pushing your assets and your application is ADB. So that's actually now 10 times faster with the new Android emulator. And of course, as Tor is showing you, we have the new UI. You can do things like rotating, take screenshots, but also there's an extended UI as well, which allows you to control sensors like taking a location, doing SMS, or making phone calls, all tools allowing you to test your application. So in addition to the local testing, we also launched the Firebase Test Lab inside of Android Studio. So if you click on that cloud tab that Tor showed in the demo, it allows you to choose devices in the cloud. And now you can run devices that you may not own and try and send your APK and test along with that to help you test your application. And as I showed earlier, we have the Espresso Test Recorder. And that's a very cool demo. And again, why this is very important is that we found that making tests can be tedious. And sometimes not a lot of people like to do it. And so now you can click on your device, we can capture all those tests, and you can now upload those to the test lab or run them locally on your machine. And lastly, we talked about the APK Analyzer. Again, why this is very important is because sometimes you think you're done, you built your application, and the APK is too big. Because at the end of the day, your users who download your application on Google Play want the smallest APK as possible. So this tool allows you to dig into your APK, look into your DEX files, your assets, and figure out what might be the problem and why my APK is large. We don't have time to talk about every single feature, but we talked about new lint analysis, new IntelliJ 2016 features, and we made a big investment to accessibility. So these are all new features that we've added inside of Android Studio 2.2. So just to recap, we launched a whole host of features around design, a new constraint layout manager and corresponding designer, new Firebase integration to help you code better, enhanced C++ support and build support, and a test recorder to help you test. And how do you get started? All you have to do if you're using Android Studio 2.2 today, just go to check for updates, and we'll prompt you to download Android Studio 2.2 and the Canary channel. And if you're not using Android Studio, anyone, just go to this Go link here and download a fresh copy. And again, change the channel to the Canary channel to download Android Studio 2.2. And that's it. Thank you so much.
Thank you very much.